if you would go to the next slide, let me quickly start off by explaining how we think we can utilize Industry 4.0 digital technologies, that includes AI and IoT to help maximize production performance. Next slide, please. Yes, so the main factor that we know that operating companies face in terms of their production challenges are, wanting to enhance their production, maximize their uptime, and to be able to improve their efficiency, operating efficiency, and personnel efficiency. So understanding these challenges, let us see how digital technology can assist with that. So next slide. So we know that Industry 4.0 concepts such as IoT or Internet of Things or cloud computing or artificial intelligence, these concepts are being introduced in the oil field, and collectively utilizing these concepts to solve production problems is what we are calling as the Production 4.0 solutions. So let's take a look further about these technologies. Next slide. So we understand about digital oil field. When we talk about digital oil field, we understand there are controllers and sensors in the field. There is some form of SCADA technology that is bringing data in real time from those controllers into the office. And then there is some form of physics-based analysis software like lift optimization in order to analyze what is happening in your field. Now let's look at how within Weatherford, we are bringing in Industry 4.0 technologies to try and address these kinds of challenges. If you go to the next slide. The first is the Foresight Production Optimization Platform. This is where we are bringing real-time data along with physics-based models to try and optimize and analyze what's happening in the oil field in real time. Next slide. The next is the Signet SCADA/IoT platform. Here is where you're bringing in data from not only your controllers, but also when IoT-based smart devices are available in the oil field, then you can bring in information from all of that equipment. And the next slide. And then last but not least is the Foresight Edge controller, which is able to not only perform traditional control activities on the well, but is also able to perform more smart device kind of activities, such as collect high frequency data, analyze the well using physics-based and AI-based models in real time, and be able to autonomously control or optimize your field equipment. Next slide, please. So let's take a little bit into how Foresight is bringing in the digital technology to the oil field and how it is helping in production optimization. At the end of the day, it is a platform that brings in workflows for your reservoir, your wells, and your facilities all into a single platform, so that you can use engineering models, whether these are reservoir models, well models, surface network models, and bring them in together to optimize your wells and utilize the operations modules in order to ensure that your field is running effectively and efficiently at all times. Of course, it utilizes some concepts of AI, such as machine learning-based predictive analytics, in order to proactively predict when a subsurface failure is likely to occur on a well. Now, the platform, because it is software-based, can run fully inside your premises, but it can also run in the cloud. So companies that prefer to run their software in the cloud can run it in the cloud, but companies for security purposes prefer to run all their software on premises, then they would run it fully on premises. Next slide, please. So at the high level, the workflows that make up production optimization starts with lift optimization, regardless of whatever type of artificial lift system you have, whether it is reciprocating rod lift wells, ESPs, gas lift, PCP, etc. It could even be naturally flowing wells. It could be naturally flowing gas wells, gas condensate wells, or oil wells. At the end of the day, the first order of business is to ensure that you're optimizing all your wells. Once you have that, and once you have information about your wells, the next step is to be able to run operations effectively. These are workovers. These could be routine well work activities. They could be just running chemical management programs, or they could be doing subsurface failure workovers. Whatever may be the case, the application allows you to manage your operations, and it also allows you to run an economic analysis, so you know before you actually do a particular workover or job, what is the incremental benefit of performing the job, as well as what are all the costs associated with doing the job, whether it is equipment cost or people cost, whatever may be all the total costs. So at the end of the day, the system will tell you what is the return on investment on doing each individual job. So you can then decide how you want to schedule your job so that you get maximum benefit out of your asset. And last but not least is the full integrated asset optimization workflows. Here is where you're combining the data from your reservoir to your wells and your surface network to ensure that your entire asset is optimized. Next slide, please. About performing these activities or using a digital solution is, like I talked about earlier, is to address those challenges to enhance production, maximize uptime, and improve efficiency. So if you go to the next slide. Normally, what we have seen is by using a digital transformation kind of solution, companies have realized a sustained gain of 5 to 15% more production, 5 to 30% more uptime, and 5 to 35% more efficiencies. So as you can see, this has a clear benefit economically, to an organization that uses such technologies to do production optimization. Next slide, please. Now, the way digital transformation works is it is a continuous process. It kind of starts with the real-time data, as I mentioned, from all the equipment that is out in the field. Then it involves automating as many of the processes as possible, such as manual data entry, data validation, bringing in real-time data, some of the other activities that can be automated on a daily basis. And then the next step is, you may have information stored in many software systems. So it is vital that all of that information is integrated into a single platform. After that, you have all the information and all the workflows to be making real-time decisions. And then the next step beyond that is to bring in advanced analytics so that the machine will help you, assist you in further making these decisions faster and quicker. So it is a continuous process. That's what is involved in using a digital transformation kind of technology for production optimization. So if you go to the next slide. Now, in a sense, there are multiple workflows that are necessary in order to do the daily activities of managing an asset. And so depending on what activities matter to your asset or your organization, those are what will become part of this continuous workflow. Say, for example, we are doing void age managing or tracking void age replacement ratio, or doing surface network optimization, whereby you're modeling your surface network and you're trying to figure out where your bottlenecks are in your surface network. Just a few examples of how these workflows become part of your daily optimization solution. So if you go to the next slide. One such example, that I'm showcasing here that works in Foresight is this integrated asset management, whereby you're getting real-time data coming from your sensors via your SCADA system into a software such as Foresight. And it enables your daily workflows, like looking at your production overview and identifying where you have some issues with production. Then comes looking at your surveillance module to see what information is coming in real time, what kind of alarms have come in, which wells do I need to pay some attention to. And then after that is to identify what are the causes of these alarms, or what are the causes of production declines, by looking at your inflow characteristics, by looking at your well test data and comparing that to what is your current production and whatnot. And you can do a further detailed analysis with the tuned well models that is built in and automated within the application to better understand what's happening with your well and what are some of the issues that are causing these production losses. Then you can look at what is your allowable production for your well. And once you have that, you can look at your surface network, and see how your surface network is doing. What is the allocation on each individual well? Compare that against your well test if necessary. And then identify what are the optimization activities that you need to perform in order to bring this production back up. And then to go ahead and actually go ahead and execute that in operations, to go ahead and perform the activity. And once that is done, you're going to monitor to see whether the benefit has been gained. And again, it continues in a continuous manner. So if you go to the next slide. So this involves numerous modules. It starts with surveillance, then there is evaluation phase, and then you plan the activity, then you execute the activity, and then you measure and look back and see whether you've achieved your objective, and then you do it in a continuous manner. Next slide. So just to at a high level, some of the examples of how this is done. Here is a dashboard that is showing you the asset and helping you, manage the production, looking at measured data and comparing it against what the model is predicting. Of course, the objective here is to look at your production and your injection trend, and to understand your overall asset performance, and to identify which are the wells that have subsurface ineffective performance, so that you can dig deeper in and find out what's going on. If you go to the next next slide. So again, one of the key concepts here is manage by exception. Now, what the software is helping you do, it is a companion. So it is bringing in real-time data automatically, analyzing the data automatically, and it is surfacing only those problems or conditions that requires your attention. So this is what is called managed by exception, whereby you only look at those wells that have performance issues, whatever are those performance metrics that you have specified, or the key performance indicators that you have specified. So we go to the next slide. One of the key things that you're doing in the surveillance module is to be able to have a dashboard such as this by looking at your wells. It doesn't matter what type of well it is, a producing well, an injector well, an artificially lifted well. You're looking at all the real-time information that's coming in from the SCADA system, and you have some quick indication if there are any alarms, what is the status of your well. You can also execute certain commands and controls right on the well from the application itself. Go to the next slide. Now, you can, the built-in well models, which are tuned automatically, will help you to quickly analyze what's happening with your well. This is an example of a rod lift well. Go to the next one. A similar example for a gas lifted well. Next slide, please. Next slide. And a similar example for an ESP well as well. So regardless of the artificial lift system, next slide, please. Yes, thank you. Regardless of the artificial lift system, you can see what is happening with your well. You can run what if scenarios, identify what may be the problem, and then come up with what is the best way to resolve this problem. Next slide. Now, when it comes to the operations module, the first thing that it does is it looks at historical production and the type of job that you want to perform, and it calculates the incremental gain in terms of production that you will get by performing this particular job. That production gain can be turned into revenue potential. And once you have the revenue potential and you know all the activities relating to this job, then the system is automatically calculating the return on investment. All of this is done even before you approve and schedule the particular job to be performed in the field. And once the job is scheduled and it is sent out to the field, if you go to the next slide, please. There is actually a handheld device that the rig crew can take where all the activities of the job are provided, and then they can just execute this job in sequence by recording how much time has been spent in each activity while performing the job. Next slide, please. So now it is also important to, with all the information that is being collected, that we have the ability to analyze that information quickly. So with that in mind, we have actually partnered with Microsoft and TIPCO to bring in Power BI as well as Spotfire into the application so that any dashboards or reports or analytics that you have built either using Power BI or Spotfire can be used as part of the application itself. This helps you bring greater insight quickly into what's happening with your asset. Next slide, please. This also, as I mentioned, the application has the surface network model incorporated in it so that you can run various scenarios around your surface network. If you have a bunch of gas lifted wells and you have a compressor that's feeding injection gas, for example, you can do calculate the lift, come up with a lift gas allocation strategy to figure out what is the optimum injection rate for each individual well to maximize production across all your wells, just as an example. Next slide. You can also integrate with reservoir simulators. Weatherford does not have its own reservoir simulator. However, we do integrate with most common reservoir simulators. For example, Eclipse or T-Navigator. So the reservoir simulator becomes part of the workflow whereby you can run production forecasting scenario. You can get the IPR from the reservoir simulator, run it on your wells, generate the well performance curves, and then pass it to the surface network to see whether the rates that are produced, the surface network has the capacity to produce that, and then initiate the next time step. And you can run this in a continuous manner until the entire forecast has been generated. If you go to the next slide. In fact, this concept was implemented at ADNOC in their gas asset. And what they realized is quickly within a few months of utilizing this, that they are seeing not only an increase in production, but a significant increase in their efficiencies because they were able to automate a lot of the very time-consuming manual steps so that now the system can actually run the forecast scenario very quickly and produce the results for them to go analyze. Next slide, please. The application also provides built-in predictive analytics capabilities. Here is an example where it is using predictive analytics to predict ESP failures over the next 15 days, 30 days, and 60 days. So by knowing when the system will fail, in this case, this is PDO, they're able to, by the way, it gives them a 98% precision, predictive precision. What that means is when the system predicts there's going to be a failure, they have determined that if they don't act upon it, 98% of the time, it actually does fail. So that is an indication that they must take some action. And by coming up with the right actions for each individual case, they've actually seen a 28% reduction in their deferred oil and a 15-day improvement in their run life of their equipment on the ESPs. Next slide, please. Now, talking about the Foresight Edge, the smart device, the edge device out in the field, well, one of the key things about the next generation automation is what we realized is it needs to be able to do multiple things. First, it needs to be able to collect, store, and analyze high-frequency data. That means the data in coming in every second, being able to store it for over a year, etc. The next step is that we needed it to be able to, sorry, previous slide, please. I need to finish a few more things. Yes, thank you. So the next step is that it needs to be IoT based, which means that when an event happens or when a fault is detected, the device needs to be able to communicate automatically to and send a notification to you rather than you wait until a SCADA system goes ahead and brings in the data. So the third step is, companies are looking to run their physics-based models, AI-based models right on the edge, right where the equipment is. And so the next generation automation needed to have that ability. And last but not least is when it has all of this information, the equipment needed the ability to autonomously optimize the well right on the edge. Now let's go to the next slide, please. So an example of the benefit of high frequency data. Here is just an example showing if you were scanning this gas lift well, maybe you're getting data once every hour, maybe a little bit sooner, depending on how good your network is. But you can, by looking at this, you would think that this well is doing fine because you're getting only infrequent data. If you go to the next slide, you will see that, in fact, if you have high frequency data available, then the blue line indicates that this well is probably actually undergoing slugging. That's the benefit of having high frequency data available to you, because if you go to the next slide, you can actually detect things like this, things like slugging, much sooner than if you have SCADA data coming in. Next slide, please. The other aspect of this is because we are running engineering models right on edge, the edge device is actually performing nodal analysis calculations with real-time data. And again, sticking to a gas lift well as an example, here, what the system is doing is it's continuously measuring injection rate, casing head pressure, tubing head pressure, and even if it has downhole gauges like flowing bottom hole pressure, it's able to measure all of that, and it's able to determine what should be the optimum injection rate in order to maximize the production by calculating the performance curve right then and there. And so by utilizing this concept, the system will automatically adjust the injection rate so that you are optimized at all times. This will avoid under injection and over injection, both of which are not optimum conditions. So the edge device has the smarts to go ahead and generate the performance curve right on the edge and actually adjust the injection rate in order to maximize the production potential. Next slide, please. Now you can actually track and monitor how the edge is autonomously controlling the equipment. Now, if you do not feel comfortable in the edge device controlling the equipment autonomously, you can turn it off and just run it in recommend mode only, so that the AI is giving you all the intelligence, but it's not taking the action. You can then decide whether you want to take the action or not. Next slide, please. Here is an example where a company in the US, when they were running the autonomous control logic on their well autonomously, it was seeing that they were able to control the slugging effects and maintain a constant flowing bottom hole pressure. Next slide, please. You can also program your own controls, and because the edge device can run on all forms of artificial lift system, you can create your own autonomous control for any form of artificial lift system. I think that is my last slide. With that, one last slide, please, and then I'm done. So in general, we have seen the Foresight system implemented in multiple installations across the world. And here are some benefits that you can see that they have realized in utilizing this. With that, I thank you. I apologize, I was running a little bit over. Maybe if there are any questions, I can answer them.